Welcome to the next video of the fourth section, Making the Game Functional. In the previous video, we have learned how to create a piece class. Now that we have all the chess pieces and chessboard-related validation rules in place, let's now add life to our chess program. In this video, we'll make our chess game fully functional. The objective of this video is to move the chess pieces with a click of the left mouse button. When a player clicks on a chess piece, the code should first check whether it's a legitimate turn for that chess piece. On the first click, the chess piece that needs to be moved is selected, and all the allowed moves for that chess piece are highlighted on the chessboard. The second click should be performed on the destination square. If the second click is done on a valid destination square, the chess piece should move from the source square to the destination square. We also need to code the events of capturing chess pieces and the king being in check. The other attributes that need to be tackled include a list of the captured chess pieces, the half-move clock count, the full move number count, and the history of all the previous moves. You may recall that we created a dummy method which is bound to the left-click event. The method for now simply prints the row and column value on the console. Let's modify this method. The first part of the code calculates the coordinates for the chess piece on which you clicked. Based on the calculated coordinates, it stores the corresponding number notation in a variable named position_of_click. Number 1. It then tries to assign the piece variable to the corresponding piece instance. If there is no piece instance on the click square, it simply ignores the click. 2. The second part of the method checks whether this is the second click that was intended to move a chess piece to a destination square. If this is the second click, it calls the shift method, passing the source and destination coordinates as its two arguments. 3. If shift succeeds, it sets all the previously set attributes to their original empty values and calls the draw_board and draw_pieces methods to redraw the chessboard and chess pieces. While coding the desired functionality for the on_square_clicked method, we called several new methods from within it. We need to define these new methods. Keep an eye on this method. This is the central method around which all the other methods will evolve over the course of our attempts to make the chess game functional. Getting the source and destination position. We have called the shift method from the on_square_clicked method. The code for the shift method is responsible for the collection of the necessary arguments that are required for the shift operation. This code first checks whether a chess piece exists at the destination. If a chess piece does not exist at the destination square, it calls on a method, shift from the controller, which is a wrapper around the actual shift method from the model class. Collecting a list of the moves that need to be highlighted. We also called the update_highlight_list position method from the on_square_clicked method. The purpose of this method is to collect all the possible moves for a given chess piece in a list named all_squares_2_b_highlighted. The actual focusing of the available moves takes place in the draw_board method of the GUI class. Highlighting allowed moves. In the on_square_clicked method, we called the draw_board method to take care of the redrawing or changing of the chess piece's coordinates. The current draw_board method is not equipped to handle this because we only designed it in the first iteration to provide us with a blank chessboard. First, let's add a highlight_color constant to the configurations.py file. Then, modify the draw_board method to handle this. Pre-move validation. The chess piece must only be moved if it does not violate the rules of the game. This pre_move_validation method is responsible for checking all the rules. If all validations pass, it calls the move method to update the move. If the rules are not being followed, this code raises several exceptions which are defined in the exceptions class. We could have further coded the error classes, but we chose not to because we simply updated the name of the error class to the bottom label, which is sufficient for our current purpose. The error message is displayed from the shift method of the view class. Though a major part of the validation check done in these lines is simple, one of the validation steps needs to check whether a movement will cause the king to be in check. This is a tricky situation. We can only find this out after we've done the actual move. However, we cannot allow that movement to happen on the chessboard. To do this, the pre_move_validation method calls a method named will_move_cause_check, which creates a copy of the model class. Then it performs a move on the new temporary copy to check whether it does cause a king to be in check. The code for this is defined here. Note that when you create a copy by simple assignment, Python creates a shallow copy. In a shallow copy, the two variables now share the same data. So a modification in one place affects the other as well. In contrast to this, deep copies create a copy of everything, the structure as well as the elements. We need to create a deep copy of the chessboard because we want to check whether the king makes a valid move before it actually moves, and we want to do this without modifying the original object state in any way. Recording a move in the data structure. The shift method defined in view.py is responsible for the actual moving of a chess piece on the chessboard. However, this brings about a change in the underlying data structure. The move method of the model class is then responsible for updating the data structure. This move method is called from the previously defined pre_move_validation method if and only if no errors are raised. Note that as soon as this update is complete, the control returns to the on_square_clicked method in view.py. The method then calls the draw_all_pieces method, which updates the view. Keep game statistics. The pre_move_validation method also calls another method called update_game_statistics on successfully recording a move. Finally, let's define the change_player_turn method, which was called from the pre_move_validation method. Congratulations! Our chess game is now functional. Let's complete the iteration by binding the File, New Game menu item to start a new game. Earlier, we defined the start_new_game method. Now, it's simply a matter of calling it from the on_new_game_menu_clicked method. Awesome! In this video, we have successfully learned how to make the game functional. In the next video, we'll see how to manage user preferences.